Hello everyone, my name is Craig Chythlook. This is ATM 101 Unit 14, Climate and Weather at Kuparuk and Bethel screencast. We are covering data and information from Unit 13, monthly station data from Bethel and Kuparuk. We are focusing on dates February 1 and February 8th and March 18th and March 22nd. We'll also look at upper air charts in comparison March 2012 versus February and March of this year. Here are the points I'd like to highlight during my screencast, and we will get started with Bethel. Bethel sits at a latitude of 60 degrees north, very similar to Fairbanks in the interior. However, Bethel is 50 miles northeast from the mouth of the Kuskokwim River. Western Central Alaska, it's a subpolar climate, but unlike Fairbanks, it is a maritime climate. So even though the annual mean temperatures are similar to that of Fairbanks in the interior, the ocean acts as a buffer to kind of keep those summer highs and winter lows a little bit closer to the mean, as opposed to Fairbanks, where we see very high summer temperatures and very low winter temperatures. The prevailing winds are out of the northeast at right around 11 miles per hour. And as mentioned, the mean annual temperature of Bethel is 31 degrees. We will look at the recorded temperatures for February 1st and 8th and compare that with the climatology mean. February 1st, we had a mean of 19.75, and February 8th, we had a mean of 29.75. February 1st, it's somewhat higher than normal, and then February 8th, it is higher than normal temperatures for this time of the year. And I believe that is due to a change in the jet stream. If you look at 2012, the jet stream is bringing in colder air from the north over the state of Alaska versus 2019 for both February and March, where we have the jet stream bringing up from the south warmer air into the state of Alaska in February and in March. So going back to the February 1 in Bethel, looking at the upper left-hand side weather chart or weather map, we see to the east of Alaska in Canada, northern Canada, there is a continental high pressure, and in the Bering Sea there's a maritime low. The continental high pressure is pushing down or diverging cold dense air, and the continental or the maritime low is bringing in humid and warmer air. So the cold dense air is pushing up the warm, less dense humid air, and that is creating condensation, clouds, and precipitation along the occluded front and warm fronts from those low pressures in the Gulf of Alaska and Bering Sea over the Bethel region. We do not see a diurnal cycle for the 1st and the 8th, at least not that I can really tell. Temperature and the relative humidity track along fairly well with each other, so I assume temperature changes are not from the diurnal cycle, but from the warmer temperatures from the jet stream and low front south of Bethel coming north or pushing north into the interior of Alaska. Looking at March, we have a little bit of a different scenario here. We do see a diurnal cycle. It is coolest in the morning, where relative humidity is the highest, and as it warms up throughout the day, relative humidity goes down and the temperature goes up. Ooh, and I forgot to mention earlier, going back to this photo here, we look at where Bethel is in relation to some of the mountain ranges. There's a small one just southwest of it, about 100 miles. and there's the Alaska Range is about 300 miles due west of the Bethel region. And what I see in here, if we look at February 8th, we have a high pressure coming up from the south of the Gulf of Alaska, pushing warm air up and over those mountains. And we can see, looks like a lot of cloud cover and precipitation, where the air is warm, humid air is getting pushed up, cooling down, condensating, creating cloud cover and precipitation as it cools. And then on the northern side of those mountains, has seen a lack of cloud cover. It looks like the air has become drier and is not showing, or we're not seeing precipitation from a small space in between the low out in the Bering Sea and the Bethel region. And I would like to speak a little bit more about the jet stream here and its possible effects on the weather, and how 2019 has differed from 2012. Looking at the middle photo here, February 2019, the jet stream is bringing up warm air from the south and kind of pushing that colder polar air from the north in towards Canada. In comparison with the 2012 picture, where we are getting cold polar air from the north covering the state of Alaska. And the February and March differences in jet stream, I'm assuming, and can account for the difference in mean temperatures on February 1st and 8th and March 18 and 22nd, and why they are higher and somewhat higher than normal for those dates. And moving on to Kuparuk. Kuparuk is at a latitude of 70 degrees north. It is 13 miles south of the Arctic Ocean and the Beaufort Sea there. It is in the Arctic region. Its mean temperature is 13 degrees. It's a tundra polar climate, and being south of the Beaufort Sea, which is for a large portion of the year covered by ice, it is a desert climate with very low precipitation, and the prevailing wind is from the east at about 11 miles per hour. Taking a look at February, we see mean temperatures for February 1st being typical for that time of the year, and then moving on to February 8th, where the jet stream is bringing in warm air. You can see the occluded front and warm front being pushed up into the Kuparuk region near a cold front, bringing those temperatures up to 29 degrees. I guess speaking first about February 1, that high pressure that is just east of Kuparuk is associated with clear skies. We don't see a lot of cloud cover in the region over Kuparuk. So what that's doing is it's just the lack of cloud cover is allowing for radiation cooling, radiative cooling in that region, and sticking with the staying consistent with the mean temperature for that time of the year, versus February 8th, where we're getting warm air coming up from the south, getting pushed up over the cold air from the high pressure to the east, cooling off, condensating and creating cloud cover and moisture and precipitation. And so we have a mixture of warm air coming up from the south, along with cloud cover holding in some of that some of that heat, and contributing to a much higher than average mean temperature for February 8th. Looking at the relative humidity and temperature, I don't see much of a diurnal cycle for February 1st or February 8th. I forgot to mention or talk about the pressure for Bethel in those slides, but February 1st, we have the high pressure kind of winning in the morning or being felt in the morning, but as that low pressure from the Bering Sea makes its way north, the pressure is dipping. And then again, once we head over to the 8th, we've got another strong high pressure to the east that is by the end of the day kind of influencing the pressure system there. And then going back, talking about the pressure system for Bethel on the 1st, it looks like it's pretty steady there, and then again pretty steady, well, a little bit of an increase on the 8th. So I guess that that may or may not, I'm not 100% sure, but I think that is kind of consistent with the thought process, especially on the 8th, where the weather and temperatures are being influenced by the warmer air from the south as opposed to a diurnal cycle. And then moving on to March 18th and 22nd, we have the high pressure holding steady just to the east of Kuparuk on the 18th. And then as the 22nd rolls around, we have that low pressure from the Bering moving its way into the region, bringing, looks like an occluded front, warm front with some warmer, more humid air. That air is again rising underneath over the colder, dense air from the high pressure, and creating that precipitation and cloud cover over that neck of the woods. And while we are up in Kuparuk, it is my opinion that the Kuparuk and Arctic region is more sensitive to climate changes because of the warmer temperatures that will continue to melt and reduce the ice in that area, reducing the albedo effect, allowing for more solar heating of the water, and kind of increasing that feedback loop into that area, allowing for more solar heating, reducing the albedo effect by melting even more ice, and kind of just leading to warmer annual temperatures overall. And with that, looking at some historical data from that region, from 1981 to 2000, the July mean temperatures were about 46.8 degrees, while over 1991 through 2010, the July mean temperature has increased to 48.8 degrees. And if it continues at this rate, it'll pass the 50-degree Alaska North Slope. The mean temperatures for the month of July may pass 50 degrees, and this will no longer meet the definition for an Arctic climate, which can be a big game changer if this feedback loop continues to grow. We keep losing more ice, we lose more albedo effect, and those summer months become warmer in that region. I guess touching up on that a little bit more, that's kind of the big one that I can think of, is that change in albedo effect, the reduction of the sea ice. We're just going to get more and more heating with more and more melting, and that's going to continue to grow at a greater rate than maybe in the Bethel region or other regions further south, because those regions do not have quite as high of an albedo effect that play into their climates. And I'm not entirely sure if the Arctic region will face similar changes or go through the same climate, weather changes as or California example where the waters, because they're warming,